Welcome back. We are now working on lesson 19's homework, and this has to do with when two chords of a circle intersect. We begin with this following question. Now, just a warning in this case that the numbers used for this situation may not work out with the numbers on from your homework because, well, I don't have the same exact measurements from the circles, but the idea is still correct. So I'll work it from there. So in this case, you're going to take your ruler, and I have a ruler here. So, and I'm going to use millimeters. Okay, so there's my centimeters and little millimeters there. So, okay, so we're going to measure AE. So let me see if I can put this over here. I need to rotate this a little bit here. Okay, so make sure I get this correct because unlike other tools, we can make them larger or smaller. This one is technically supposed to be the same exact measurements because this is your measuring segments here. So I got AE to be about. It kind of looks like 3.7 centimeters. Okay, so since 3.7 centimeters really is going to be, in this case, 37 millimeters. So we'll go 37 millimeters. All right, and now to measure BE, I'm going to move this over a little bit here. And now I'm going to slide I'll move in this case move from this end and concentrate backwards. Okay, so, all right. And it looks like in this case, 15, 14, 13, so 2 points, it looks like 2.8. So 2.8 centimeters is 28 centimeters. Okay, so that's 28. Okay, all right. And so now we're going to measure, in this case, DE. So let me swing this around. Okay, move this over here. All right, so put the 0 point here, and I'll turn this over. Okay, yeah, swing this around, and it kind of looks like DE is about 3 centimeters. Okay, so yeah, I'm gonna go 3 centimeters, so that's 30 millimeters. And in this case, and so from the 3 to E to C, it looks like about 3.5. 1, 2, 3, about 3.5, maybe 3.5, maybe, yeah, 3.5, so 35. Okay, so based on measurements, let's find AE times BE. Well, let's see now, AE times BE, so we're going to do 37 times 28. Let me clear all this. So 37 times 28, and we're going to get 1036. Okay, so 1036. And now for CE times DE, that would be 35 times 30. So 35 times 30. So 35 times 30 equals 1050. Okay, so 1050. Now they're very close. They're very close to a theoretical relationship. We're off by, like, I guess it would be here by, I guess, it can't really call well, it could be 14 millimeters squared technically, but it's not with area though. So they're very close. Now, why isn't this? So we would say it's close. All right, but why isn't exact measurement? Well, because in this case, so we're not using. Okay, and here this is really the big reason. So we are not using precise tools. I mean, you might say, well, your computer is pretty precise, Mr. Young. It's pretty good. Well, yeah, it is, but again, I'm eyeing it here, and I might be off by a little bit. So being off by a little bit, you multiply with something makes it even worse. But it's pretty darn close, though. So the idea here is that the product of the product of the segments here, let's go here, talk about this. If two chords of a circle intersect, then the product of the parts of one chord are equal to the product of the parts of the other chord. And so I give an example here of in this circle, we have chord A, B, and chord C, D intersecting at P. So based upon this, we see AP times PB, the product of those two pieces of the first chord, should equal to CP times PD, the product of the pieces of the second chord. Okay? So this is the rule we're going to use. And now let's take a look at the next problem, number 2. And so in number 2, circle K, diameter TW, so it definitely goes through the center, intersects chord RS at X, such that the measure of the arc SW is 38 degrees. Okay. And the measure of arc WR is going to be 98 degrees. Okay, so which of the following is the measure of angle WXS? So we're looking for this angle here. Well, here's the thing. We have another theorem that has to do with the second chords, and so here we go. In a circle, if two chords intersect, the measure of the angle formed angle formed is equal to. Sorry, I put the word by. I'm not sure why I put there. So is equal to 1/2 of the sum of the arcs intersected by the angle and its vertical. So, okay, what does this mean? Well, all right. So you have, if two chords intersect, it's not like a center angle, and it's not like a inscribed angle. However, the angle formed is, since you have two angles that are vertical to each other and must be congruent, they intersect two different arcs. So, example here is in circle O, chord AB intersects a chord CD at P. Angle APC, this angle here, is congruent to angle BPD because vertical angles are congruent. And those two arcs intersect, so two angles intersect two different arcs. First, angle APC intercepts arc AC. And angle BPD intercepts arc BD. And so those two arcs are both involved because they're both intersected by the vertical angles. Therefore, we will take the two arcs, which will be definitely, they could possibly be very different measures, and then add them together and divide by 2. Really, you're taking the average of the arcs. Let's go back to our problem number 2 then, using the same idea. So we want to find this arc here, because that's the arc intersected by angle WXS, but we also need to find the arc that's intersected by its vertical, angle RXT. This arc here. Ooh, I'll use red instead. Okay, so. Now, we don't know the arc, but we do know that we have a semicircle, and that's 180 degrees. So 180 minus 98, meaning arc WRT minus arc WR will give us arc RT. And so in this case, we're going to get 82 degrees. Now, it's not on the scale, so. Okay, and so we are going to we now found arc RT, okay, and we now found arc WS. We will say the measure of angle WXS is equal to 1/2 the measure of RT plus the measure of arc SW. And therefore it is 1/2 the sum of 82 plus 38. And here 82 plus 38 is 120. And half of 120 is 60 degrees. And therefore, we're going to get 60 degrees. Okay? All right. So let's try question number 3. All right, so this goes back to question number one problem. GH and EF are intersect at K such that EK is 5. So EK is 5. And FK is 6. GK is 3. And we want to find GH. Well, we know FK, because two chords intersecting in a circle, that the piece FK plus KE must equal to the piece of JK times KH, because two chords intersect the circle, the parts that form the product of parts of the first chord equal the product of parts of the second chord. And so now we have 6 times 5 is equal to 3 times x, or 30 equals 3x, leaving us with x equal to 10. So the measure of KH is equal to 10. Okay, ladies and gentlemen, so this ends the first part of the review for homework number 19. I have to make sure that there's enough time to cover all the questions. And if you found this helpful, please make sure you hit a like on the video. Please leave questions and comments on the section below, and make sure to subscribe to our channel to make sure that you get the notifications, internal notifications, that you get notified when our new video drops. Okay, so I will see you in the next video. I hope you enjoyed this. Okay, take care and be safe.